While we're waiting, does anybody want to volunteer to help the AI take notes? Otherwise, we will just probably rely on it. Could someone also close the back door so we aren't hearing the general hallway roar? Instead, we'll hear doors closing and opening occasionally. Okay, welcome to the Quic working group meeting at Ietf 126. If you have not already, please log in with the Meetecho tool, the on-site tool. At this point in the week, you may have already seen this, but just as a reminder, we operate under the note well here. Please review it if you have not, and even if you have and haven't looked at it in a while, please also review it. The meeting tips, as I said, please do use the on-site tool. This is how you will queue for the mic, both and remote participants you already know because you're there, but also please state your name before speaking in the queue. This is especially helpful for the note taker, the AI note taker in this case. And yes, these are just links. Okay, admin, I already said, unless anybody here is really enthusiastic, it sounds like we're going to rely on the AI note taker. The chat is in Meetecho and Zulip. We will manage the queue. You can remove yourself, but if you don't, I will kick you out anyway. Okay, so working group doc status, it's a little bit leaner this time. The main thing is that reliable stream resets is now in last call through August 3rd. So, woohoo. And everything else, there's updates to various working group documents that we will be covering in this meeting. Otherwise, we have a bunch of documents that are awaiting various things like Shepherd write-ups. So our agenda is a little long in terms of number of items, the number of things in the working group that are related to adopted work. We're going to spend some time on QMUX, extended key updates, accuracy of timestamps, and then QLog. And then we have a relatively substantial portion of time dedicated to, as time permits, topics. I will not read them all. They are there. Some of them are interesting, of course. Does anybody want to bash this agenda or reorder things, anything like that? No. Okay. And then with that, I guess we will go to our first presentation or discussion, which is on QMUX. Yeah.
Hi folks, I'm Lucas, taking my chair hat off and presenting on behalf of the QMUX authors today, and I'll have Eric helping me towards the end of that session. Wherever you are, I can't see you, but if you're not here, I'm worried. So yes, that's that. Since the last IETF, if my maths is correct, we've published 2 drafts, the draft 01 and the 02, being that we had adopted QMUX 00 into the working group. We had a lot of issues that Kazuho presented at 125. So we've discussed those previously. Those were wire-breaking changes from 00 to 01. And then from 01 to 02, just trying to close out remaining issues. I'd say that no wire-breaking changes. There were behavioral changes in, say, tightening of text about how a peer should respond to some kind of frame or something. So behaviorally slightly different, but effectively same wire image. Some of those key changes briefly are to use QMUX records. So this was the kind of 2-layer encoding question that we discussed last time. I'm not going to go into all of the details. It's not a good use of the working group time. I'd encourage you to read the latest draft if you haven't, and you can go and look at section 3.2 about how those QMUX records work. We had some kind of issues relating to how to define to use QMUX over TLS. We all agreed that we'd want to do that, but the required use of ALPN, which helps in somewhat for people who are developing application layers to decide how they want to use QMUX. So some text on the guidance there, which I'll touch on before the end of this session. Allow the use of reset stream at, very straightforward, and just general hardening, cleanup, and clarification. So I want to take some time to look at the implementations before we get into some of the problems, just in case people haven't been tracking. There's been a lot of activity in various statuses. We had some of the kind of early adopters of the work, people who are interested or enthusiastic about QMUX prior to adoption. So we've got Quickly, HA Proxy. Anything on this slide was my quick survey. If there's any inaccuracies, that's my fault, and people can correct me or incorrect in the chat. But from what I understand, we've had various levels of implementation from projects like Move Fast, Pico Quic. There's a QMUX MS Quic fork, but I think the MS Quic folks are interested in doing it their own way. So there's some work going on there. I had a fork of Cloudflare's Quiche that I then went on and vibe coded a curl backend for to do HTTP3 over QMUX. So demonstrating the composability of the libraries and the layers. There's a Quick Go fork I've said, but I believe now it's a PR to Quick Go. Although we've had some other work in the space of kind of libraries that are being developed within the web transport mock world, both a Rust crate and a NPM thing, whatever they're called, node thing. And then the final one was tooling around this thought experiment of how easy or hard it would be to do a Wireshark dissector. So I put up an MR for that I haven't linked. It still needs a little bit of polish up, but it was kind of easier than you might anticipate due to the reuse of the existing quick handling, which is part of the value proposition that QMUX suggests it has. So implementations on their own are not great. The question has kind of been in the group of folks in this slide, what is a good driver for interop? You can have a client and server, but what should they do to connect and exchange some application data? Some of us have been using HTTP3 over QMUX. Quic in general has used a form of HTTP to drive like a request response echo, client and server to drive streams. Kazuo and I updated a non-adopted document that defined how to do HTTP3 over QMUX, very short draft. It defines the ALPN token, which is important for the negotiation of using QMUX. And although this text is taken from the draft and says it uses QMUX version 01, because 02 is wire compatible, there's no need for another ALPN right now. I presume once we do a breaking change, we'd probably want to do a different one and rev that, but that's not something the working group needs to worry about too much itself. We've also heard that MOQ over QMUX is a popular target amongst that group of people. I can't speak much for that myself, but there's these kind of different subpopulations of people who want to do some things. There has been interop success between those people. I was trying to capture that back in the Slack, and unfortunately the history didn't go back far enough for me to make that comprehensive. So the results of capturing those results has not been so great, and I'll try better to do that in the future so I can present a matrix of things like we're used to in the past. But in addition to that, Marco has been doing a work in progress quick interop runner thing for QMUX. So I think that would be another thing for us to explore. And also just to highlight that some of the implementations have been doing more than just QMUX over TLS. So looking about how we can do this over things like Unix sockets or web sockets, changing the substrate underneath. This is just a quick view of the Wireshark dissector to show you that it did actually work. And it presents the information in a way you might be familiar with if you did TLS dissection ever. You can see that it's a TCP running over, TLS 1.3 running over TCP with a client and server hello. They've negotiated this ALPN I just mentioned, highlighted in the red box. I'm I'm not going to go into this in too much detail, but you can see exchanging the the QMUX transport parameters, including the max record size, which relates to the change to the two-layer encoding that we did, and then exchanging HTTP3 data over the top. And what was cool is the HTTP3 dissector just needed some glue to be able to pick up and hook into QMUX with no other changes. Now, onto the meat of the issues. We only have 4 issues, which is kind of surprising. We thought we might have more at this stage, given how many we closed out previously. And just in summary, could QMUX optionally leverage this existing TLS Quic TLS negotiation? Should we require TCP, which is more of an editorial issue about how we frame some of the discussion about the substrates? Something about QMUX and the provided ALPN, and a more recent issue about revisiting some of the newer text about graceful close and some of the requirements we put on endpoints or suggestions we made to those endpoints to do anything. Eric, do you want to come up to talk in detail about these issues now?
Okay, not a ton to go through here. There's only 4, as Lucas said, which I think is less a sign that there are no issues and more a sign of, please read the latest version of the draft. The first one is more of a larger question of, do we want to have this document be talking about just QMUX over TLS over TCP? Do we want to include the current discussion, which is already in the draft, about HTTP Connect and Unix domain sockets and all that kind of stuff? Right now we have ALPN for TLS. We don't have that for Unix domain sockets, etc. Do we want to allow any transport that's suitable? What's the plan there? Do people have any thoughts, opinions? We can also take that same discussion to the issue. Marco, I see you're in the queue.
Yeah, I mean, I would want this to work over any suitable substrate. But I'm curious to hear if anyone has the opinion on why you would only want to constrain this to TLS over TCP.
I think some of the subsequent issues we'll talk about, what do we do for insecure substrates, which I think was a large part of the motivation. But mechanically, I don't think it's that different. Kazuho.
Kazuhoku. So I think one of the problems of talking about talking about substrate other than TCP is that they could have different ways of closing. I mean, TCP that has a very specific way. I mean, fins are unidirectional, whereas RSTs are bidirectional. So at least in the QMUX draft, we have to say exactly when using TCP how the connection should be toned down. But for other underlying transports, we cannot really say anything without specifying which ones do we want to support. So I'd probably say that the best direction is specify what we would be doing when using TCP, and maybe add a section saying that if you are using something else, then it's up to you, or something like that.
Yeah. I think that's kind of a reasonable middle ground where we say, these are the properties that we need, right? Like we need some kind of application layer protocol thing, not to finish the acronym. We need some way to say this is closed and this is done. And then this is the distinct mapping of that to TLS over TCP. And if you want to define a document that is your own mapping, then like you should probably write down how you chose to do that if you want anybody else to talk to you. In a very similar vein, the next issue is about what do we do if one of those non-TLS things isn't secure? And so the question came up, hey, we kind of banned these crypto frame things that Quic has from QMUX and said, nope, you get all of that from TLS. However, if you were running this over some other substrate that didn't have TLS already, or where the claim is that it is challenging to add TLS, why not just use Quic's crypto? I think based on the discussion on the issue and kind of where I'm personally ending up without any hats on, is that we probably don't want to add yet more combinations of ways you could run this. It'd be nice if there was just one thing, and if you needed security and it was easy enough to add QMux, then it's not totally clear to me why it's hard to add TLS and then QMux. So if anybody feels strongly or feels differently, it would be great to hear more about that. And we have a queue.
Hi, so I'm one of the people that was asking for, could we get TLS frames or quick crypto frames directly in QMux? The main motivation is most quick implementation already come with all the TLS machinery implemented in. And so in terms of implementation simplicity, if we can just simply say, keep it in, do the same as is already implemented and get cryptography and security for free, it is simpler for some use cases. It is possible to get TLS or TLS layer implemented below. That's something that is doable technically. We are talking about code, everything's possible. It just seems more complicated. But there might be additional challenges with making it work inside of QMux when looking at the details. That's a part I haven't explored yet. So
Yeah,
that's just a big question, a suggestion. I would like to see if we can do something there. It's not something that I have solutions for.
yeah, I think it's also a complexity trade-off with having multiple modes for QMux. And one of the benefits here is the thing that you'd be running outside as TLS is the same TLS as you're running inside of Quic. So if you have it well enough to operate inside your Quic implementation, there's a good chance that you at least have some of the support for running it outside. Two more.
Lucas, speaking as an individual, I commented on some of the issue. I'd really like to keep the current design and to avoid some of the complexities there. So I'd love to punt on this for the time being.
Alan van Del Meta. I also think we should not do this now, but I think maybe if somebody is really interested in running this mode, can't they just write another document that you would shim between your substrate and QMux in the future? So it doesn't close. If we lock it out now, it's not for closing that door forever if that's how you want your stack to work.
Yeah, that's fair. That's not a hard no forever. This is an extension that could work. No, looks like Marco's last, and then we'll keep going.
Just a quick note from the implementer's perspective. I thought doing as what we have right now with QMux sitting on top of a TLS stream was very straightforward and simple.
Gotcha. Thank you. There we go. We talked in the previous slides about, do we restrict QMux to only TLS versus not? This one is hopefully fairly straightforward. We're saying if not running over TLS, one of the things, I think Kazuho framed this nicely, like this is one of those things that we need something for. And the draft currently talks through how you do that for TLS. I put some options here of kind of things that people had brainstormed in the issue of ways to negotiate the application protocol. One of them is say that's a you problem. Go figure it out. Enjoy. One of them is to say you have ports. That's what ports were for once upon a time. We could also build in a QX transport parameters or LPNs thing. And let's build a queue and maybe close a queue because I see we are at time, but I believe this is the end, almost the end.
Christian Uitema, I'm all for the U problem solution because I mean you're not going to do everything, and the obvious candidate that we've heard after TLS or TCP TLS is Unix socket. So if people really want to run QMix over Unix socket, maybe they should write a draft and put the Unix socket stuff there. That's
Gotcha.
Alan Frindell, I'm a little sad to lose this piece, but I maybe don't have maybe Christian's point is right. Like somebody who wants to run this over something else can go think about it. I wonder, was it in the issue, like what they're, what the use case or why they were, what was the substrate they were thinking?
Yeah, like so you wanted to run this over Unix domain.
It was Unix domain. Yeah, I mean, the thing about ALPN is that you actually, it's not, or ports, for example, you have combinatorial explosion. Like right now, you know, some of us support 5 different versions of the mock draft. And so
Yep.
the negotiation piece is like useful.
Cool.
So Lucas, again, speaking as an individual that commented on the issue, my concern is if we did something like the third option here of providing another negotiation mechanism, we end up with considerations of, well, we want to use TLS, and what if we sent these additional messages, whatever they would be, that would try and negotiate a different protocol, and you end up having threat models about protocol mismatches, etc. So I personally, I'd love to punt on this for now, and if people want to go away and think about it harder, again, not shutting the door to it, but just let the authors focus on the most minimal solution for the stuff.
If we have an easy enough extension model with the transport parameters, it's not super hard to add what actually is useful in real life. Mm-hmm. Okay. This one, I don't think we have a ton of time to talk about, so I will simply say, go read the issue. I think it was Corey did a very nice write-up in the issue of why, especially mobile devices that are powered by batteries, care hugely about not being woken up to be told that the connection you had that was idle is gone now. It's kind of like knocking on someone's door to tell them that they should be asleep. So go comment on the issue. There's a little bit of complexity there around, can we make silent close happen for idle connections? But otherwise, my take is it seems like a pretty good idea. And that's it.
Yep. So thanks. Yaroslav, do you want to come up? You're next. Yeah, next step. So I'll close the issues on QMUX and keep iterating and implementing.
Hello. It's been a while since we spoke about extended key update. As a reminder, idea of extended key update is to introduce post-compromise security in Quic. Compromise is always a bad thing, and if you know that you are compromised, then you should do something about it, not just do some kind of remediation and keep going. But quite often you don't know that you are compromised, and that's a problem. So with regular TLS and Quic key update, you get fresh keys for AAD that are derived from the very same shared secret that you got during the initial handshake. So it does not help with compromise. So if somehow somebody stole traffic keys from the application memory, your session is compromised forever and ever until you terminate it. With extended key update, your blast radius is reduced. You make a fresh extended key update that includes doing a fresh key exchange, and that minimizes or reduces amount of traffic that attacker could steal if they manage to steal your session keys. Now, what happened to the draft? So Quic extended key update draft depends on TLS. Extended key update draft, we decided not to create a completely new mechanism for Quic. There are a few differences that I'll cover in a moment. So TLS extended key update is going through formal analysis, expected to go through working group last call soon-ish. So once that happens and once we get initial implementations of Quic extended key update, I suppose we will also be asking for a working group last call for Quic extended key update. There is a chance that as a result of formal analysis, we might have to make some changes to TLS extended key update. So we really have to wait for that. For TLS extended key update, we have two implementations, one that is based on embed TLS and another on Rust TLS. I am working on Quic extended key update implementation based on Rust TLS Queen. So if anybody wants to participate in interoperability testing, please reach out. Would be great to do that. As a recap, in recent changes in TLS extended key update that are also relevant for Quic. So in the past, when I presented it last time, we had separate messages, separate TLS handshake messages for extended key update request, response, and new key update. That was deemed to be wasteful. TLS messages are very scarce resource. It's a single byte type, so they have to be allocated very, very carefully. Now we're asking for a single extended key update message type with 3 subtypes: key update request, key update response, and new key update. So we're staying consistent. New key update cannot be used, mustn't be used in Quic, because Quic has a key update bit flag that we are rotating in the very same way as key update, the standard key update works. IANA registry will be requested for potential future extensions, and I suppose we will have a separate column if this subtype applicable to Quic or not. Other change, there are no more failures in TLS extended key update, so it's always expected to succeed, not necessarily instantaneously. So you could potentially delay before if you really feel like it, but there are no more error codes, which significantly simplifies the specification. So if responder is too busy, it may delay the response. And if you're requester and you didn't receive response in timely fashion and you're not happy with that, you can, well, terminate the connection. Another recent change based on initial results of FAT, formal analysis feedback, is we are mixing in initial transcript in TLS extended key update. So TLS extended key update now carries continuous transcript of all handshake messages. Previously, it started fresh transcript every time. So formal analysis people told us that it would be much better for the security properties to keep the same transcript, which we are doing now. And our prototype implementations were updated accordingly. And it was not really a big deal from an implementation perspective. So right now we are, again, hopefully soon we will be doing working group last call in TLS working group, getting few more quick implementations, and if nothing dramatic happens, we'll be asking for quick working group last call as well.
Cool, thanks, and thanks for giving back some time. Is there anyone who wants to ask anything or say anything on this topic? Or Magnus?
Magnus Westlund Eriksson. Yes. I should review the draft better, but I mean, this overrides the no further TLS crypto frames after handshake complete, doesn't it?
It uses TLS crypto frames after handshake is complete. Actually, you can and should be using TLS crypto frames after the handshake is complete today to pass new session tickets.
Yeah, but I think that's the only message that was allowed. So I mean, you're writing, this extension to replaces some of the
so it will be leveraging crypto streams with this special stream in the very same way as new session tickets is using that.
But no, it's good. I will review this better and hopefully provide some comments because
awesome.
I think because it really is needed in a number of use cases. I think I talked to Alvaro about the potential use of BGP over Quic, and they have really long decision. They're gonna need it.
Yes, again, the motivating use case is all sorts of long-lasting connections over Quic, such as VPNs and IoTs, and perhaps BGP, where you do want some form of post-compromise security. Great. Thanks again. And yes, we are very much looking for volunteers for interoperability testing who would like to do implementations, and of course, reviewers. We need more of those. Thank you.
Thank you. Next up, we have received timestamps.
Okay. Can you hear me in the room?
Yes, we can hear you.
Okay. Well, good morning, good evening, everyone. I'll also have a short presentation on the Quic packet receive timestamps draft. And this is, I'm Joseph Vishay. This is a joint draft with Ian from Google. So in case you haven't seen the draft recently, this is just a quick overview. The draft enables the peer to report packet receive timestamps for some or all ACK packets. The timestamp is connection local and not intended to be absolute. And the current version of the draft uses new ACK frame types that extend the existing ACK and path ACK frames with receive timestamp information. And where we are right now is version 3 of the draft. We've only had editorial changes since the last Ietf. to clarify some details about what it means to have max receive timestamps not be sent at all, or if it's sent with 0. We clarified that 0 means that you cannot send the frames. And we added the security considerations section. There were some suggestions that were raised in an issue, so we used these to add the section. And we currently have one open issue that Victor and Ian suggested, like they opened while adding the implementation for Quiche. And this is the issue: is do we need specific guidelines for rejecting implausible timestamps? We say that the timestamps are best effort anyway for the sender side, but this adds like for the receiver side, when we currently already say the draft says you should do plausibility checks and you may ignore implausible timestamps, but we don't provide concrete heuristics. Victor and Ian suggested 2 specific heuristics. So just soliciting more feedback. Do you think we should include guidance on heuristics to reject implausible timestamps? And are there any others besides the 2 that Ian and Victor suggested? So I'll leave that up for discussion in a minute. But the quick like implementation update: MoveFast supports the latest draft version. It's not enabled in the internet, but it's in the code, and we can set it up on one of our interop endpoints if you want to test against it. Google Quiche has support for the latest draft, but the transport param negotiation is still planned. And what we really are looking at this point is more eyes on the draft. Is there anything you would like to see added, fixed in the draft? Any editorial or clarification suggestions? And if anyone wants to do it or not. So with that, I will just leave it at the issue that we have open. And if anyone has any questions, comments, clarifications on the draft. Yeah, Ian.
Ian Sweat, Google. I just wanted to add that I have spent too little time thinking about what the rejection criteria should be. And so like these are like the definition of like me thinking for like 10 minutes. Unfortunately, Victor did come up with a case where you could basically persistently like just move time. I think it was like more slowly, like at the half the rate of actual time. And if you persistently do that, you end up getting persistently 2x the bandwidth measurement that you would expect for something like BBR. Unless, admittedly, we do other things in our BBR implementation, like limit by like the send rate and stuff. But like the point is, it's fairly trivial without some sort of rejection to end up with like extremely large misestimation in bandwidth. So my inclination is to say we probably need a recommendation, a should, or something with like a plausible heuristic. And so, but I'm not an expert in this area, and like, you know, I would really appreciate anyone who is to suggest something. So.
Alessandro Ghedini, Cloudflare. I think regardless of the specific heuristics here that might need more thinking or review, it would be useful to include guidance if we think that you like an implementation would for sure like need to implement this. And even if you leave room for an implementation to do something else, having like a specific guidance that, you know, by default, you probably should do this, but then maybe if you have a reason to not do this, then whatever. So if it makes it easier for an implementation to not have to think through too much if it's like common logic that most people should probably implement anyway.
Yeah, that makes sense.
Got it. No hats and no confused. So yeah, I think we need to write down good rules for this, and we need to kind of do some sanity checking for really strange paths and see what happens. And I don't understand the rules at the moment, but that's probably just because I can't squint at it properly.
Jonathan Lennox, maybe this is just because I'm old, but I remember the days when you couldn't rely on your peer's clock crystal being within 20% of yours. I mean, it's probably not that bad anymore, but the things could legitimately have a clock that's running faster or slow. I also mentioned on the chat that TipTop is going to have to worry about cases where time runs faster or slower at your peer than it does for you, because they're on Mars and you're on Earth. But yeah, I mean, I think you're going to have to, any timestamp based thing is going to have to be robust to the peer behaving oddly just because they're weird, even if they're not actively hostile. So I think maybe there should just be general guidance of when you write, and maybe this should be not specifically for this, but something in CCWG for timestamp based congestion control algorithms. I don't know.
Yeah, sounds good. Ian and I will try to put this in a PR and see and share it with everyone to get more feedback.
Yeah, everyone who's commented, please review that and engage in the discussion on the issue.
Okay, thank you very much.
Is that it? Okay. Qlog is up next. So typically we might just do this as a quick chair update, but I wanted to put some slides up for some visualizations, presenting on behalf of the four authors, Robin, Luca, Martin, and myself. Since IETF 125, we have published some new drafts. The key changes are numerous design changes I'm not going to go into, individual events, fields within events, optionality, consistency, numerous editorial improvements, not including my misspelling of numerous there, but to keep going through and refining text, taking text out, things like that. I expect some of that to continue as we drive towards working group last call, but some of the key non-changes are that the fundamental design and foundations are not changing. We've sorted the extensibility model out that we're fairly happy with, which I'll touch on in a couple of slides. And we closed out the JSON sec versus JSON issue that had been rumbling on a little while and deciding to close with no action. So we've kept the JSON sec serialization. I'm sorry if that makes you feel sad, but it helps unblock us as one of the fundamental serialization design challenges that could have affected progressing this draft. It means the authors don't have to do any work and we can focus on other things. So to go back to implementations and interop again, there are varying levels of support of Qlog versions across the implementations because we have been iterating. I'd say now is a really good time to update to the latest draft. We're going to keep touching a few things, no doubt. That's just the process. But fundamentally, if you're on a very early version of the Qlog drafts, now would be a great time to switch to this one. AI and LLM does a really good job of taking these structured definitions of things and looking at your existing code. If you have code, or if you're just regexing and print effing, it could probably figure it all out. So it might not even be too much work. In addition to that, we have a new parser tool. This is a logging and analysis observability kind of thing. So while I had a lot of loggers, the parsers were far between. So a chap called Pat Meenan, who people might know from the web performance world, has developed something called waterfall tools. This is coming from the world of kind of web perf analysis, web page test, if you may have heard of that or ever used it yourself, but trying to abstract the visualization of things like page loads that do multiple HTTP3 or HTTP requests on a connection and making this a more reusable library, again, developed in Node.js, I believe. I opened an issue in May to be like, it'd be really nice if it could also do Qlog. It can analyze HAR files, if you're familiar with those, or Chrome Netlog files. Saying the time's over, but I just forgot to reset the timer for myself, but I'll try and be brief. This is an example of what I mean by the waterfall example. So this is a request on localhost loading 5 different resources. They've all got different color depending on the phase of the connection. This maybe resonates with some of the stuff going on in Happy, trying to identify what the user agent was doing in the time that wasn't just about something active on a single transport layer connection. The interesting thing there as well, I tried to highlight in the red box, is you have kind of these banding of colors that shows the data delivery for that resource. So beyond the when did it start and when did it finish, TTFB, TTLB, you get a better sense of when were key elements or bytes of that resource delivered on the wire, which could indicate things like prioritization, head of line blocking, loss retransmission, etc. In addition, Pat then kept iterating, and he's taken QViz and somehow embedded it into this tool. So we've got the familiar sequence diagram from Robin Marks's QViz tool there that we're familiar with. And then in addition to that, he's taken Chrome's netlog viewer kind of view of the events that were happening and a way to go through them and extract, render some of the details on the right-hand side. So anyone who's familiar with that world, that's that too. That's pretty cool, I thought. Now for open issues, we've only got 4 of them. Unlike previously, we're not going to go into these issues. I don't think it's a good use of time other than one of them. And again, we might run out of time for that one. But these are the 4, 2 related to zero RTT and session tickets and settings. If people feel passionate about those topics, it'd be really nice to get some input on the tickets to drive them to closure. We have one issue 501 that the editors and authors can probably figure out amongst ourselves. And then this last one that's the most recent about frames processed I wanted to go into because it's new. So this is a consistency issue. And a brief history was that Quic frame, the traditional logging of those was in packet sent and packet received events. You have an array of frames that you say, oh, I received this packet, and the frames are in it, say. But when I was trying to use QLog for QMux, because I love both, we don't send packets, and therefore visibility of frames was trickier until I realized we have this existing frames processed event, which got me thinking if we could repurpose it in some way to indicate if the frames were processed because they'd been received or sent. After some discussion in an editor's call, we figured it would be better to have separate frames created, frames parsed, and frames processed events, which are effectively similar to the existing frame created and frame parsed events in HTTP 3. So we've added two events, frames created, frames parsed, and left frames processed there. So now we end up in this kind of similar but different mode, and that's where the inconsistency is coming. We wondered what we should do, and I'll present 3 options on the next slide. But for context, this frames process event is kind of a bit of a weird thing. It's part of the use case was that it can be used to signal internal state change, not resulting directly from the actual parsing of a frame, i.e. you could have parsed the frame and then buffered it to action later and then action it later. You could, but I don't know any implementations that would operate that way, or even if they did, if they need a standard event for doing this kind of thing. So I can imagine 3 proposals here. We remove that frames processed event. The original purpose to separate out packet handling and frame handling is now achieved by frames parsed, say, or frames created, etc. For the overall consistency of these drafts, we add a frames processed like event to H3, or we just do nothing and leave it as it currently is specified in the document. I don't want to spend too long on this, so maybe if we lock the queue map, that'd be good. But yeah, Kazuo, go ahead.
Kazuo, so I'd prefer removing it because we will be having other problems if we try to fix these things. For example, QMax allows streamed processing of frames. So if you have received partial frame, then it can still be processed. So there are these kind of issues that keep coming on. So let's keep it simple, close it, and then if we find anything in the future, then we can change things.
Yep, thank you. Who's next? Christian.
Yeah, kind of same opinion as Casio. Let's not do that in this quick frame process. There are events that are legit in quick frames. for example, says to you receive an extension of flow control.
Okay.
But they can be treated as their own events.
Cool. That's a good signal for me. It's easier to add things later than try and deprecate or take them out later. That's the kind of school I'm subscribing to. So great. That's a clear input to the authors. Next steps, please help us. We've got the session tickets, zero RTT stuff. Beyond that, I think we're really, really ready for working group last call, even though we said this 100 times before. And just to flag that we want to be able to support new Animage and QLog drafts or schemas that are building on top of this work. It's really important that we can get the foundations done to unblock some other work that's been happening, such as Careful Resume. Mira's got a draft for Happy to support Happy Apples v3, and there's some other things that are going on there. So things are progressing well, and it feels like we're very nearly done, which is exciting. Florentin, reverse so quick. Oh, and yeah, that's the end of the adopted working group item. So in the as time permits bucket now.
So, hi everyone, I'm Florentin Rochev from the University of Namur in Belgium. So I'm here today to talk about memory copies in networking implementations. Usually when I do some netcode, I can end up with having to copy information, so copying data, and this is usually expensive. I'm trying to avoid doing that as much as I can. And in the case of Quic version 1, there is still one memory copy that I cannot really avoid. So let's take, for example, so we receive 1 megabyte of data from the network. So this megabyte is encrypted. So we have to, this has to go through the Quic stack. And in any Quic stack, it's going to decrypt these megabytes as many different packets. And then we have a stream frame inside the packet that we will want to extract and give to the applications. And there's usually two kinds of way to extract that. So either we copy inside some kind of buffer that the application is providing, or we just give the stream frame as is to the applications, and the application has to do the rebuffering itself if it wants to. What I want to do to have is have some kind of contiguous zero copy in which from the network layer to the application layer, there will be no copy happening, and the applications can have this 1 megabytes of contiguous data if it wants to. To do that, we need to actually refactor the protocol, and that's the proposal today. So there is actually 3 changes that are necessary from Quic version 1. The first change is to add 2 elements in the Quic short header. These elements will be a stream ID and an offset. They will be used to select the buffer into for the decryptions and to locate where to decrypt. Second change will be the stream frame. The stream frame should be the first elements inside the packet. And then any other, of course, control frame can be after the stream frame. And a third change will be the ordering of frame elements that will need to be reversed. So this change is a bit uncanny, certainly. But yeah, with these 3 changes, we can have this contiguous zero copy property. So we can have this situation in which we have no copy in between the network stack, the network layer and the application layer. So how does it work? So basically, you can see here in the middle. So we have a buffer containing multiple Quic packets, so 2 Quic packets. And when we decrypt, we are actually using the decryption hidden copy, so the out of place decryptions to recombine the stream frame. So we end up to a contiguous stream of data, and there is no copy anymore that is needed to recombine the information. So we can recombine because we have information in the Quic short header to do that. There are different solutions to than reversing all the frames, but these solutions for reversing is interesting, in my opinion, because it minimizes the information in the short header. And we can come up with a nice abstraction in the code, because reversing gives us a symmetry with Quic version 1. So we can actually write something like this, for example, which we are here. We have one frame. If we want to parse the frame or to write the frame on the wire, we can actually use the same code, because the relative order of all elements is the same. So we have this buffer here that is an object that is hidden the fact that the buffer can be from left to right or from right to left. So in the case where it's reversed. So basically we can have the same code for the two versions. With that, of course, this proposal has some benefits and some drawbacks. So we'll suggest just to leave this slide up, and I'm just going to take any feedbacks, comments, or questions for this idea. Yeah, thank you. Questions?
No one? Kazuo.
Kazuho, thank you for presenting this. I think this is an interesting idea. I like the fact that when you actually encode it, you don't need to calculate the, one of the complexities that we have in Quic version 1 is when you encode it, you don't know the size of the frame header. So the position from where the data starts changes, and it's kind of hard for us. So I think, if this was proposed during the development phase of Quic version 1, I would have preferred this approach.
Okay.
Though honestly, I'm not sure if we want to do this now that VI has already shipped, but other than that, I like this idea.
Yeah, I think it's a good point. Thank you. We can also think about the new protocols that are being designed today, like QMux, for example. So if we have this kind of reversed frames or designs, then QMux will inherit this property as well. So it can still be useful for ongoing and new designs in the future. Yeah.
Brian? I took myself out of the queue, so don't come up.
Hi, Brian Trammell, clarifying question. This would be Quic v3. It would be wire format and uninteroperable with one. So if you have one endpoint that wants to do the zero copy, that would only happen if the other endpoint also negotiates.
Correct.
Okay, cool, thanks.
Kyle?
So making sure I understand, this is achieving zero copy only if you already have a copy during decryption.
So decryption also always copies. So when you decrypt, you have to put the data somewhere. Usually it's in-place decryptions, but most cryptographic libraries let you choose the destinations. So in this case, you choose the destination as being the stream buffers, and you are going to override the previous control packets of the previous control frame of the previous packets. So it's the same cryptography code that is being used. I don't know if that answers your questions.
But you're assuming you have to copy from some memory that you can't decrypt in place from.
So the point is you have to have out-of-place decryptions. So most cryptographic libraries have out-of-place decryptions. Even in-place decryption is a copy, but it's a copy aliasing on the same destination, right, than the source.
Hi, Lars Eckert. So I think I read the paper a while ago. I don't remember the details, but I'm assuming you're presenting the same thing. So I think it's a clever hack. You get some performance, you avoid memory copies, which is nice, but I'm kind of wondering how many deployments have that as their remaining bottleneck.
Yeah, I don't know.
Okay, that's a fair answer. Thank you.
Well, I mean, on the main bottleneck, I just put that in the chat. The memcopy is not the remaining bottleneck that we have in Pico Quic. The main bottleneck is basically complexity, and so adding more complexity is kind of debatable. The question I have is that the scenarios that require that tend to be served today by RDMA. So have you done a comparison of Quic enhanced to do the zero copy on receive stuff and RDMA? Because I don't know, but I mean, it's not clear to me that people who are really performance constrained will use Quic with extension versus RDMA.
Okay, it's not necessarily clear for me as well. So I suppose that if someone has a use case that will benefit from zero copy, this can be useful for them. But yeah, I don't know whether RDMA is going to will benefit from that.
Chair interrupt. We're just at time. So Ian, if you want to make a quick comment, we'll take that. But yeah.
Ian Sweat, Google. I think to echo Christian's comment, I think this is an interesting idea. I like the fact that you're experimenting in this space. If you're going to break the wiring format or like make it different, go for it. Like go way farther. Like way farther. Like think about RDMA. Think about like all the things they do, and think about things like, do I even need to put control messages in the same packet as a data packet at all? Like go farther.
Okay, thank you.
And yeah, just to close out that talk, thank you for the presentation. These are not adopted work items. We could get into them. If there are people who feel really inspired or enthused about this, do communicate and do keep doing the work on this, because performance is a complicated story but important. So yes, thank you. Up next, we have CTAPs. If you want to come up, Ingrid.
Yeah, hi guys, my name is Ingebrigt Hoven. I'll be talking about CTAPs. This is based on a paper we submitted to ANRW, and it's also been my master thesis for the last year. So transport services in general, it's a layer between, essentially a layer between the application and sockets and other network settings. So it allows you to not have to bind tightly to specific APIs, but instead helps you state your intentions and communicate over the network in an intention-based way. So the vision of transport services in general is to have a single interface for more than just automatically or like more than just selecting transport-related protocols, but you also have common policies which can be used to set things like DSCP. For this example, there's no way to directly set DSCP through transport services, but instead you can state that you want a low latency interactive connection, and then the library itself is supposed to do whatever it can to actually achieve that. And it's also supposed to, transport service in general is supposed to help ease protocol adoption thanks to a happy eyeball style racing of protocols. So CTAPs in itself it's a CE implementation of transport services, and it's the first open source transport services implementation which supports Quic. This now comes with certain gaps and that are more or less inherent in transport services as it stands now, and this is what I'll be focusing on. So first of all, there's a slight gap in exactly how connections are closed in transport services. So a quick connection maps to this TAPS concept of a connection group, while a stream maps to a TAPS connection. This mapping doesn't necessarily fit that well for TCP. So when you're closing a TAPS connection, it makes sense for TCP to initiate graceful teardown, while for Quic, it makes the most sense to send a fin, but to remain open for receiving data. This isn't inherently problematic, but it's an example of this is supposed to be a generic API where you don't actually notice which transport protocol you are using, but here it's bleeding through to the actual application. There's also examples where you lose granularity through transport services. For example, if you're aborting a stream in Quic, you can both you can send stop sending, you can send reset stream, while for TAPS you have a single abort implementation, so you lose this directionality that you have if you use Quic directly. There's also no way to establish directional streams as of now in transport services. So for TAPS, directionality of a connection is stated before the connection is established, and cloning, which is a concept that is used to later create streams on an established connection, doesn't have any equivalent way to set the directionality of the resulting stream. So there are several mitigations that it can be made in transport services to better support Quic and to fix these gaps. For the granularity problems, it's naturally that you would update the TAPS API. You could add optional flags and new parameters. This is something that would, for example, be easy to do in CTAPS, but then you would deviate from the actual transport services spec as it stands now. For the closing semantics I talked about earlier, this is perhaps a bit more complicated. What I've found is useful, at least when writing applications using CTAPS, is to assume that you're using Quic all the time, and then only interacting with the connection group, and then you will get this consistent behavior no matter what. But this is an example of the underlying library actually forcing the applications to be written in a certain way, which is not ideal. So to conclude, I think transport services is useful and it could help for wider protocol adoption. Application level protocols can be written on top of it and use Quic, and then receive TCP with more or less free fallback. But there are some gaps that exist, but they can be mitigated through careful design, and it could be all. This is fairly relevant for later work. There's been some discussion for having TAPS as a basis for networking in the C++ standard library, things like that, and then it would have to take this into account. If you're especially interested, you can find the source code and my thesis on my GitHub. Thank you.
Yep, and thank you. And as a reminder to people, we're not the TAPS working group. We can't necessarily talk about those things, but personally, what I found quite interesting on this was the powerful feature set of Quic streams and how the APIs to those are maybe not necessarily there from this layer, at least. And some applications don't need that at all, but where they are critical to those apps, it's something for us to consider. Let's get to the queue. Ted? No, Ted. Ted is Todd. Jonathan?
Oh yeah, Jonathan Lennox. I mean, this is maybe a little bit cynical, but given how much TAPS is a generalization of Apple's network framework, I would say do whatever Apple did. And also, I think there'd be useful. I think the TAPS working group is closed. It'd probably be useful to have AD guidance of where things like this should go. Maybe it's TSVWG, but it's probably not here.
So, hi, Brian. Yep. Brian Trammell. I think it's very interesting that you did a thing that was not just what Apple did, right? Like, so this is another sort of way at the implementation. So really, really excited about this work. It's pretty cool stuff. I find it really interesting that when we were doing TAPS, we pointedly did not include Quic. as one of the protocols that we were targeting, because Quic was in flight at the same time, right? Both these things took a while, and it's like, no, we're in scope only to do Ietf protocols, and Quic was not yet an Ietf protocol. And then, I said this, I think, at the mic in Wit area, that I think there is a gap in having sort of like standards or standard-ish APIs on top of Quic in order to actually drive adoption beyond where we are right now. So this is really cool stuff. I will be taking a closer look at it. Thank you.
Thank you.
And just as a quick reminder, there was a draft for Quic taps that was floated around a while, but it didn't progress.
Eric Kinnear, Apple. This is really cool work. I would also suggest you not do what Apple did. Not because I think there's anything wrong with it, but because I think we benefit from having a diversity of the different ideas and experimenting with different things. So I think doing other things is great, and then let's look at what works the best, and we'll all move in that direction together. So this is very cool work. Thank you for doing it.
Thank you.
So just as a clarification question, if there are people that want to discuss this more, like we don't think this working group's a good venue, is TSV, I'm getting a nod and a thumbs up from our responsible AD, Gori. So yeah, folks, please take it there. Thank you.
All right, thank you.
Yes. Next up, we have Magnus.
Yes, Magnus Westlund, and now for something different. Now we get into ciphers. If I get some slides. So the shares did an interesting interpretation of my title, but this is about the talking about trying to introduce GCM SSTs in Quic. Thank you. This is a draft in actually towards TLS currently, because it's registers both TLS and Quic and DTLS. Me and John co-authors. So a bit of a primer between GSM SSTs. SST stands for strong secure tags. It's an EAD algorithm. It's documented in a CFRD draft, individual currently. It has been standardized by ETSI and 3DPP. There's 2 independent security proofs. It uses basically the same cryptographic construct as ASGCM. The main difference here is really how it derives, and it derives new authentication keys for each AAD invocation. So for each packet in Quic terms, you will derive new keys before you do the calculating the authentications. And this addresses a weakness in normal ASGCM, which uses the same authentication key for all invocation. So if you ever crack that key, which becomes fairly simple, which is why in this table in GCM, for sure, where you say forgery probability of the first forgery is basically going towards 1. You almost you get most bit of the key with one single forgery. So in a few forgery, you will definitely have the key. And that makes it hard to truncate this tag and with maintain security properties. GSM SST is defined for AES 128, so with 128-bit keys, 128 blocks. AES 256 with 256-bit keys and 120 blocks. And also Rindal with 250-bit keys and 256-bit block sizes. And looking here at the strength, you can see that an GCM SST 12-byte tag, so basically saving 4 bytes, we would still have 5 bits better strength in the authentication than Poly 1305. GCM is a bit more difficult to like a very straight comparison, but it's roughly the same, at least roughly the same strength level, if you take into consideration that you if you ever would have a forgery. In this case, you would have one forgery and only one forgery. With GSM, ASGSM, you would, if you ever have a forgery, you can have multiple forgeries. I mean, we'll come into where these properties might matter in Quic further into this presentation. So how do we use this in Quic? We are proposing now a 12-byte tag and a 112-byte tag. And the 14-byte tag is considered definitely stronger. We are using the same ECB as ASGCM for the header protection. And one thing that happens when you go to 256 block is that you actually need to extend the sample extension for deriving the input for this ASCB. So we do that basically by just padding out it. But that ensures that even also short Quic packets can be authenticated with Rindal. So this is the currently proposed cipher suite names and their parameters. But yeah, this is the current proposals. They are definitely up to be changed if people have ideas about what should be most appropriate. So the benefits here is really that we can truncate the tags, and this MSST truncated tags behaves ideal when you're using them in unicast and with replay protection. Then you get the forgery probability of approximately 1 divided by 2 up to by the power of t, where t is the tag length in bits. And as I said, the kind of big difference here is that with SSTs, you get one single forgery if you ever manage to do a forgery. You have no further information into the next packet or so to be able to forge. If you have ASGCM, you basically get the collapse and can do additional forgery afterwards until a rekey happens. With the 12-byte tag, we would say 4 bytes per packet. And you also, if you would go with Rindal, you would get a significantly larger parameter space. It basically removes all practical limitations around invocations, even decryption invocations. The other limits are not that restrictive in Quic usage. You're going to be restricted by other usage before. Anyway, so where it might be matter more actually is in multipath and multicast. Maybe take multipath first. For ASGCM, you use the same. Each path in multipath uses slightly different nonce construction that normal Quic, which means that the path is part of the nonce, which means that you can actually, in your attack here, use all the paths, which these have individual replay windows kind of behavior because you have different packet number spaces for each path. And you have multiple different paths to spread your attack load over. So it enables a bit of this scaling of the attack with the number of paths you're using. For GSM SST, you need to target one specific nonce. So if you can't actually send the same attack traffic to multiple different paths. You will have to attack different keys if you send to different on different paths. So you maintain an ideal behavior in multipath with replay protection, etc. So multicast, we have a multicast extension proposals. It might something happen, but if people goes in this, they might have to consider this behavior for ASGCM because basically you can get an attack surface improvement by trying to send different attack packets. If you have enough capability in the network to send different traffic to different multicast receivers, you can try significantly more packets. So you basically get to this probability to forge something becomes V times R divided by 2 to the T. So how much traffic you send to an individual and how many individuals you can send. You can scale up the attack. So, and after you made the forwarder with ASGCM, you could actually tailor packets to particular receivers. So we are going to try to now push this with the security proofs in place. The standardization happened in its in 3D-PEEP, etc. We will work in CFRG for getting that process forward. But it would be helpful to see what interest is here in Quic for this Cypher suite, or Cypher suites, I would say. And is there other authentication tag? Are there interests, etc.? You can think a little bit about what it's implicate. Try to think about what the implications are with, and how much, if you have a need for saving more, etc. But considering what attack surface and attack probabilities you're after. But the advantage here is really that yes, you will have different properties in SST because you get one forwarder only means one forwarder. That can, of course, have substantial damage to quick connection if you can actually flip the bit rate. Like for example, you can reset streams probably if you know things like that. So it might have implications. So, but yeah, I think I'm done. So if any feedback to this.
Speaking as a chair, so some of the kind of off-lifts feedback was whether, if this kind of work should be discussed in the Quic working group, not this talk. Obviously, this is a FYI to kind of the folks in the room of some work that might be happening. But if there is interest, then what would an appropriate venue be? And if people have thoughts on that, that would be interesting to hear.
Hi, Lars Eckert, Mozilla. Not a security person, even when I'm more awake than I'm now. So wouldn't this need to go into TLS? And
yes.
Okay, and once TLS thinks this is the hot cheese, we just do it?
Yes.
Okay.
I mean, basically, we did the draft which is currently targeted to TLS, would register the necessary TLS cipher identifiers, the parameters, etc. And it also defines the header protection for Quic, so you can use it for Quic too. So
okay, that sounds like what I thought would happen.
Yes.
And I mean, I'm not qualified to evaluate any of this, to be sure. I'm not like saying this is bad or this is good. It's just like,
no.
I want TLS to tell me we should implement this. Thank you.
But they tried this a little slightly different in TLS versus maybe Quic for certain aspects. So that's why I'm bringing this up here. I will talk in AVT Core where we have a completely different set of traders also. So, but there we're going to talk even shorter tags than this because. So
Martin Duke, Google. This is cool. And yes, like most of the work is in TLS, but I'm intrigued by the fact that I think there's some weird rough edges in doing, like if you just have a TLS implementation and just one day it starts negotiating this thing, like all our Quic implementations will break because the tag links will be wrong, right?
Why would that? I mean, the tag length follows the ciphers.
Yeah, but like the sample. But you mentioned the sampling has to change for like minimum packet size, for instance, changes.
No, it doesn't. That's the thing. That's this. By doing what we've done, doing this draft, we ensure that it's not changing. We're using for the shorter for AS128 and AS256 that use 128-bit blocks. It has the same property as current ASGCM. We need the same amount of sampling to create for ECB there. And we basically fix the 256 block sampling by padding it out so that it will not break. So.
Oh, so you are going to tag 16 bytes onto the end of the packet, even though you don't need that.
We sample what's currently defined as a sample, and then we expand it with an additional 28 bytes of zeros just to make it ensure that it works.
All right, then never mind.
Yeah.
It's easier than I thought.
So this is, we're trying to fix these kind of, which otherwise would be rough problems. So.
That said, there's like probably a minor editorial change like 9001 to authorize this cipher, but thanks.
We've got 2 minutes, so please be brief, Christian.
Yeah, I mean, I love these things. I mean, we should have crypto agility, and if TLS allocate a code point to say, hey, use GSM SST, and we negotiate that, it should just work. Emphasis on should.
Yeah.
Because in theory, all the code paths say, hey, the size of the checksum varies, is a function of the algorithm. In practice, it's always 16. So there's a tension between what you should do and the fact that 16 actually works quite fine today. And I predict that there will be a couple of bugs to fix.
Yeah, it might be. I have to check this again, then, but yeah, thank you.
David Skenazy, Google. Just to respond to the last two comments, that's not how the interaction between TLS and Quic works. We very much cannot just grab something, a code point from TLS, and put it in Quic. And I know you're not suggesting that, to be clear. I'm just responding to Martin and Christian. If you take AES CBC and put it in Quic, the wire format will work, but it'll be completely unsafe because your counter keeps increasing. So explicitly in all the Quic implementations, we have a specific allow list of the TLS ciphers that we allow with Quic, along with whatever the parameters, like the min packet size and all of this. So that makes sense. Like, we'll have to add them one at a time. That's how we'll get agility in Quic. I think, like Lars said, we'll want to see what the cryptographers really think, but they'll need a bit of input from us, and by us I mean Quic, because I think the innovation here is multicast. With TLS, you can't really do multicast TCP, and I think this is where it matters more, and that's the input that they need to know that this matters for them, that then they can bring it back to us.
Yeah.
Okay. We're at time. I think there's clearly a subset of people who'll get really excited about this stuff, but the rest of the people are just staring at the floor. So I'd encourage those folks to get together. You know, if there are inputs we can give to other groups that are considering this work, that's going to be valuable, even if it's something we don't do here, or maybe we don't do here right now. So yeah, good stuff. Max, please come up. I'm going to go get some water because my throat's killing.
Hi everyone, I'm Max from Mozilla. I want to give a quick client-side perspective on the adoption of HBS RRs and Quic v2, and this is based on Firefox's telemetry set. You can download the slides, and there you find links to the public telemetry, as in all of this data is public. For a browser, there are two ways to upgrade to HTTP3/Quic, which is one out-service HBS headers, and then two HBS RRs via DNS. Today, the majority of H3 upgrades Firefox does is over out-service HB headers. What this means is that Firefox always has to do, or any browser has to do, an H1 or H2 connection, and then learns the out-service H3 signal on that connection, and then only on consecutive connections can it do HTTP3. And the alternative is HBSR, where we do a lookup in DNS before even establishing the first connection, and that way we have the H3 signal right away and can connect over HTTP3. Now, we as a browser are obviously very eager to see more HTTP3 and are very sad when we can't do HTTP3, even though the origin would support HTTP3. So why is that relevant? Here again, as a diagram, either via alt service, first connection is definitely not H3, later on consecutive connections can be H3. HTTPS records, on the other hand, we fetch them via DNS right away, and the very first connection can be HTTP3, and so we reap all the benefits of HTTP3 on our connections. Where do I click? Second interesting perspective from Firefox's telemetry, we enabled Quic v2 recently. For those that don't know, Quic v2 is functionally identical to Quic v1. It just greases a couple of values, so we don't ossify the protocol long term. After having it rolled out, we see exactly, well, close to 0% of Quic v2 and 100% of v1 still. that matches other measurements. Why is that? A couple of implementations implement Quic v2, a couple don't, but really the drawback, the main drawback is that most deployments don't deploy v2. Yeah. Now I understand that there's not much value in deploying v2, but if we want to prevent as a working group that Quic does not get ossified, I think this is a good step forward. So I encourage everyone to implement and deploy Quic v2. Now, to push all these efforts forward, I built a little website. It's called savearoundtrip.com. You can learn what HTTPS RR is all about in Quic v2. And then you have a little check where you can input your domain, check whether it does HTTPS RRs, what those are, how you could if you don't have them. And it will do a quick handshake to that endpoint, and we'll do it both of v1, offering v1 and v2 only. And that way, check whether the domain offers either or both. So with this small slot here, I want to encourage you to check your domain, then publish HTTPS RRs so browsers can do HTTP3 on the very first connection, and to please turn on Quic v2 or implement it. Thank you.
Thanks, Max. And this is just a short kind of snippet of some of the work that you've been doing and presenting in a more fuller form elsewhere, right?
Mm-hmm.
Yeah. So folks are really keen on learning more. Do reach out to Max because he's got it. David.
Thanks, Max, for doing this. This is really cool work. Just David Skenazy, Google, briefly. We've implemented Quic v2, but we didn't deploy it because Quic v2 does not help with ossification. There is no way to know a priori using the HTTPS record or alt service that a server supports Quic v2, so you're still stuck using Quic v1 for the handshake. You could do a compatible version handshake to v2, but that's actually doesn't help with ossification because you're still sending a Quic v1 initial. My understanding from chatting with you recently is that Firefox remembers the support for v2 and can use it later, but that's still going to be really small numbers. If we wanted v2 to be useful for ossification, we would need a way to discover support through the HTTPS record.
Well, I guess, so currently we offer, I guess, v1 and v2 as a client, and then we do grease the download path, right? As in the offer then decides for v2. So that would already work here. Firefox today does not remember that the server spoke Quic v2.
Okay. Then I'll blame Martin Thompson for lying to me. The ossification is on the upwards path because that contains the SNI and other parts of the client hello that are kind of hashed into the JA3 and all that by all these kind of boxes that prevent DDoS. I'm not aware of anyone looking at the downward path, so I don't think that'll help us much. Like, it's really the upward path that we need to grease and prevent ossification on.
That's a good point.
Okay.
Cool. Thank you.
Thanks. Okay, I'm back again. Hopefully my last time. So this is an individual talking about an individual draft, not adopted or anything. This came out of a discussion back in Montreal around lunch. I can't remember who was there, sorry, but it was like, oh, it would be like, you could do all this stupid stuff with Quic and like, you would never want to do this. So I wrote a draft about how you could do it. Thinking it was a good idea at the time. The more I consider it, the more I'm talking myself out of the idea. But then other people were like, oh no, like that makes sense now. So this is why there's a question mark. I'm not presenting this because I think it's good or it's valuable, but that I would love to capture the discussion about some of the stuff this relates to in case it helps inform other similar discussions about mutating any other transport parameters in Quic. And maybe if I can take you through the thought process, we can capture this in the recording, and next time somebody comes with a similar kind of idea, we can point them at me failing, I see Brian's already in the queue. I mean, give me a break, man. Yeah, okay. So we start with a quote. This is Eric Idle. We're talking about idle timeouts. You're here and then you're not. Quick connections, maybe if you use Magnus's draft, they're going to last forever. But realistically, they're intended to be created and then closed at some point. Quic goes into the details about how we can open and close connections. One of the ways of doing this is via the idle timeout. So this is just text taken from the RFC. Each endpoint advertises this max idle timeout, and then the effective idle timeout for the connection is the minimum of those two, kind of. Not precisely, depends how you like doing maths. But the things I've emboldened here to focus on some of the things that kind of stick out to me. You have the parameter name, but you've got either endpoint can do things. The outcome of if you do negotiate the idle timeout is that the connection is silently closed, which is one of the good features of Quic that helps save things like radios from needing to wake up to send a message to say I'm going away. Both endpoints can agree that at the moment in time, based on some of the maths, that they will just blow the connection away and move on and do their own things. But that if you do agree on a max idle timeout or an idle timeout for the connection, the endpoint commits to initiating an immediate close if it intends to abandon the connection prior to that effective timeout, which I don't remember ever reading that. It does make sense, but it gives you a slight pause for thought sometimes. Just to illustrate how this thing works in practice, say we had both a client and a server just there. They're configured however they are, maybe a static configuration or a browser default behavior that end users cannot modify themselves. Client here is advertising 30,000 milliseconds. That's what the units of the transport parameter. The server would say 60. And in this case, the effective idle timeout would be 30,000, so 30 seconds. If the server had advertised max idle timeout 0, i.e. it didn't want to use idle timeouts as described, the client still trumps in this case. So it's not always the min, it's the min, but 0 is special case, which is okay. 0 can also be represented as not sending that transport parameter at all. So omission would have equated to the same thing. And this kind of makes the transport parameter a bit weird when you look at it in the light of some others, which I'll come on to on the next slide. But just doing a very quick AI-powered survey of what different implementations tend to have as defaults. This is not exhaustive. Some of these are libraries that are then used by their respective applications on the top and set different values. Do not put too much stock in what is put here. I probably make mistakes. But interestingly, there's lots of folks picking 30 seconds, discussing some of this surrounding the corridors. Some of that seems to be inspired by the whole NAT timeouts being around 30 seconds and trying to keep connections kind of alive or something. Maybe one of the comments is you shouldn't be using idle timeout to try and get around NAT issues, but I think that's probably its own research topic. We then got to kind of step up to 60 seconds. And then this kind of cluster of people setting much larger values or indeed just setting no default whatsoever. I can't talk to those other than Cloudflare's quiche. And our approach was, well, the library itself shouldn't be having an opinion on this. It's an application matter. Any default we pick is probably not going to be the right value, like a Goldilocksy problem. So by setting none, maybe that helps. It gives the initiative to the peer who also has a say in this discussion. So to kind of try and frame all of this mess together, I can make some assertions that I don't necessarily believe hold anymore. But that the max idle timeout is unique across all of the transport parameters that Quic defines, in that it is an actual negotiation. A lot of parameters are defining things you're willing to receive, or at least the initial value of things you're willing to receive. And then at runtime, you're going to keep modifying that, say, the initial flow control for a stream, and then giving back more stream flow control credits. Or other properties to do with the connection that would maybe hold once and be used by the peer to continue speaking to you in the future, but that are not negotiated, they're just more statements. The other assertion is that a client could advertise multiple ALPNs, and that the same idle timeout would apply to all of them. Why? This needs to be there as probably not going to have time to get to, but it was important in some of my reasoning around the problem statement for the draft. A single application protocol can have multiple use cases. So something like HTTP 3, you're going to use ALPN to negotiate that, but the use of HTTP on any given connection could be wild and varying. You could have standard request response coupled with mask tunneling, coupled with web transport. You don't necessarily know precisely what's going to happen on a single connection until you've made that connection and start to see what's happening. Therefore, coming up with a static declaration at the start of the connection is maybe not ideal. You can have different life cycle events within a connection. Although Quic doesn't define a graceful close mechanism itself, HTTP does. And that, in addition to things like TLS, either server authentication or client or client authentication, application protocols might have their own models, and it's good that they do. And so moving on from that, I'm not going to ask people to prove them right or wrong again, we don't have the time, but to go into some of the details of this H3 go away, effectively, if a server sent one, it's telling the endpoint not to initiate, or the client endpoint not to initiate any new requests. The connection is kind of going unidirectional at that point. The thing that's going to keep driving the connection, if we ignore pings but focus on application data, is the responses coming from the server, which limits it slightly. And one of the open questions is, if you know you're going to go away and you send the data, do you then send an immediate close as required by RFC 9000, or do you stop sending responses and then wait for your 30 seconds idle timeout that the client negotiated? If that's the case, perhaps, just perhaps, renegotiating an idle timeout at the moment you sent the go away to something shorter would allow you to, from an application, push some of the timeout management you might be doing in your layer into the Quic connection, and just let the idle timer look at exchanges of packets and data, maybe. So if you wanted to negotiate, which I don't think you probably do, but if you wanted to, here is a way you could do this. Either endpoint could request an update to the idle timer for the connection, and the peer would then accept or reject that. And you would lock this with some sequence numbers, and you'd have to have some DOS considerations about not changing the timer too often and not going forwards and backwards in time. And you end up with actually a lot of complication here for what should be something that was maybe be a simplification. And you could also disable the timer altogether. So you could grow or you could shrink the timer depending on the kind of use cases you got. Which leads me to thinking, would this cool thing you can do as an extension to Quic actually solve any real concrete problem? I don't know. Which then leads on to any other transport parameters that you might want to change to solve other problems too. And therefore, if there's more than one to do, then we should have a generic way, maybe, or probably definitely not. And I'll finish there. Brian?
Yeah, so I'll be honest, I put myself in queue primarily just to argue against whatever you were, wherever you landed. But I think the answer to these, now I have a serious comment, right? No, maybe yes, in that order.
To these questions.
These questions, well, no asterisk, right? Like, so depending on how complicated your multipath situation is or whatever's going along your path, or you get like re-natted onto a thing where the big use case that I think is useful is if you were trying to maintain a long running connection without doing a reset and you get re-natted onto a different path and you notice it. Not sure how you'd notice that, right? Like and then magic occurs. But I really like the mechanism that you came up with in trying to solve this problem that might not exist. So I think that's worth talking about.
Okay, thank you. We are at time, so if you could be very brief, folks.
Okay, Ian Spike, Google. I think a number of comments that came up. One, and we've had bugs with this ourselves, the most important thing is that if you idle timeout early, tell the peer. Because it turns out if you don't, and we've had this bug, like it really does cause tail latency problems you don't want to deal with. So like, fixing your implementation is probably like step 0 in this. Chrome's also implementing or experimenting with the 300-second idle timeout. It is plausible that might happen the next few months. And so like the internet's not quite so ossified maybe as we thought. How much of this is like the lack of a go away at the Quic layer? And instead of putting, and then the other question was, settings make me sad in HB2. So like making any of the stuff updatable gives me like trauma. And I don't know, I'm not really sure if you actually if you negotiate this extension, do you need to be able to reject it? I mean,
there was a reject at the idle timeout.
You already said that you negotiate, like you support the extension, like you get what you get, you don't get upset. Like now it was just like a go away or like close the connection. Anyway.
Okay, cool.
Mia Kulevin, do you have any data how often you close on idle timeout or on regular close?
I don't know.
Would be nice to have some data. There might be a problem.
It would, and if anyone would like to volunteer data too, I think that would maybe help this kind of discussion.
And on the other questions, actually, yeah, maybe there's a general case for it, probably not for all parameters. I tried to just look at the RC, but the data tracker didn't load, so I don't know.
Okay, thanks.
So I kind of went the opposite way. When I first read your draft, I totally disliked it, and I'm starting to like it more and more. The reasons are I like hole punching. I like connection migration, and having different timeouts for different paths that you're using seems very useful. I also like mask protocols, and they have very different properties than H3, as you said, and being able to act upon that seems very useful. Would updating other transport parameters also be useful? Probably, but I'm kind of scared of doing this, so I would like to not do that in this draft.
Okay, thanks. And it does remind me, I forgot to put on the slides that I think multipath does change some of the design rationale we had for the initial approach to idle timeout. But I'm going to try and get people in the corridor and discuss this some more. So thank you, everyone. Who's up next? Yes.
Hi, folks. Max Franke from TU Berlin with your favorite topic, multicast. Actually mentioned for the second time today, thanks to Magnus. So yes, we talked about multicast in Quic before, but today we want to talk about it again because some things changed. A lot of external things changed. And today we want to talk about real-world use cases. We want to talk about actually running code and some of the implementations we now have, and why it might now be finally the right time to add multicast to the Quic toolkit. What we will not talk about today is any technical details on the drafts. There's two, any implementation details, anything like that, right? Nothing about adoption, nothing about the inherent trade-offs you get with multicast, right? Which are about privacy, security, and so on. But we just want to show what we actually did here and how this might be a good thing for Quic to have, right? But we're of course happy to discuss all of these issues offline or on the list. Okay, so really briefly, multicast, many people might not in this room, I mean, most of you will know this, but multicast is actually used today on the internet, right? There was, in mobs yesterday, there was this panel discussion from some operators, and Broadpeak, they use multicast ABR to stream some of the games of the last World Cup, right? So there are legitimate use cases and there's legitimate use of multicast today. The problem is that the delivery path is quite complicated. The solutions that are out there are all very, very much proprietary, and they're also not that secure. But even though these issues exist, right, it is still being used on the internet today, interdomain. Okay, so why do we want multicast in Quic? Well, Quic runs over UDP, so it's a very, very natural fit for multicast, right? Quic gives us a path into browsers through web transport and so on, so we can actually have a realistic path, and I will show you, or we will show you with one of the implementations that is actually there now to have multicast natively play in the browser, right? Again, this has security and privacy implications. Not going to discuss these today, but it's a feasible path. With Quic, we get provided get security and reliability, which again, if you do it with UDP, regular multicast, you have to add a lot of stuff on top of the UDP multicast to have things like fallback and reliability and security, encryption, and so on, right? But also very importantly, Quic gives us a full end-to-end solution for this multicast. And we don't need 100 different delivery paths. We don't need 100 different options and middle boxes and whatever to get multicast working. We can just get it with Quic end-to-end completely. And of course, Quic is designed in a way that it allows for extensions to fit cleanly. So getting multicast into Quic is actually kind of elegant, right? And it's not bending TCP or whatever, making it somehow work, but you can just quite naturally get it in. Okay, so to the running code, we now have 3 implementations, and they are basically on various different levels of complexity. At the hackathon on the weekend, and Louis will talk about this in a second, we got a very minimal implementation. Then we have the FlexiCast implementation that was presented before. And then now we also have a running media over Quic multicast implementation that I will talk about afterwards.
Thank you. So yes, I'm Louis. So this one comes from the hackathon we made this year. So the idea was to start from Quic and see what we have to change to have a minimal working multicast in Quic. So we had this hackathon, we modified 6 implementations with not that much line of code. And as we can see here, the basic idea was just to announce the multicast tree where you can receive the multicast data. So that is one change. The second one is to be able to open a multicast socket and then finally to receive the data. So we made this during the hackathon. I promise that at least one of the 6 implementation was written by a human. So we can do this in a single day. And then as a use case, we use RTP. And as you can see, we managed to make an RTP stream over this implementation running on the laptop and also even on iPhones. So it's just to show that it worked. This one? Oh, yeah. And then that was a previous work where we used multipass to do this more cleanly. So it's a complete design, complete implementation, but it's much more, it's much heavier because we require multipass and modify multiple things inside Quic, but we could show that we can scale to a lot of traffic.
All right, thanks. And now for the media over Quic multicast extension, right? So this is based on the one of the 2 drafts, and it basically uses the existing mock architecture to, again, relatively naturally fit in multicast, right? Because in mock, just very briefly, you have the relays, right? And what we did with this implementation is basically then that your mock relays, they will just emit multicast, right? And in addition to the regular unicast channels. So what happens is that the client just connects to the mock relay like it would do any other way. It will get the traffic over unicast, but at the same time, it will negotiate multicast support through the extension we implemented. And again, we implemented this. This is in a browser, right? It's in an extended or modified browser based on Firefox. And it will negotiate it. And if multicast works, right, you will exchange some frames, you will announce some multicast channels. The client, the browser in this case, will try to join this multicast. If it succeeds, then you will get the data over multicast, and the unicast transmission will stop. And for this, we use reliable stream frames, right? Because that's what mock uses. And basically, you get the scaling benefit, right? And for this implementation, we also used integrity frames as an additional layer of security, right, to make sure that you can't inject traffic. So yes, this is basically the model really quickly. Again, if the multicast doesn't work, the only thing you actually lose is that you add a few frames at the beginning of the connection, and after that, it's just a regular, normal, quick mock web transport connection. So there's no additional overhead. There's no issue if the client doesn't support it or anything, right? You don't have to jump through any hoops to get this working. It just fits, again, very naturally in there. And it's like this opportunistic approach to multicast, where you get the benefits of it without having too many of the drawbacks. So if the clicker works. Right. So as I mentioned, it's seamless for clients, right? We tested it again in the browser with a couple hundred of clients, and if the multicast traffic stops for some reason, you don't see it in the video. If you switch from unicast to multicast, you don't notice it as a client, as a user watching the video. And I think on this plot you can tell when so this is the egress, right, of one of the servers for this. And again, this is running on the internet today, right? You can just go to our demo website and build the demo version of Firefox to just use this. And you can probably tell when I turned multicast on and off, right? Just based on the egress. So even with this very naive implementation that is not optimized in any way, shape, or form, including integrity, including all the overhead, you can still get an egress traffic reduction of over 80% already. And the added latency you have for the multicast authentication and everything is around 60 milliseconds, right? So it's, again, even in this naive implementation, you already have quite significant benefits. Okay, yeah, this is a QR code to the repo where you can try it, and the website. And again, what we want, or what we would like from the Quic working group is discussion on these implementations, discussions on the use cases, right? Also with the perspective of discussion that happened yesterday on how you can get more Quic adoption, right? And maybe adding features to the Quic toolkit that can't be done with TCP and old H2 and so on, could be one option to extend the Quic landscape with, yes. Okay, thanks.
Just as a chair, I see there's quite a lot of chat that the speakers wouldn't have been able to benefit from. So if you made a comment, I'd like to invite you to the mic as well, just to perhaps verbalize that if you'd be comfortable.
Gary Fairhurst, what about congestion control? Because that's where Jake left the thing, I think.
I mean, we wanted to discuss multicast congestion control, I think, in 2 IETFs ago in CCWG, and nobody really cared there because there was no application for multicast. So chicken and egg problem, right? But we have solutions. We have solutions on how to deal with this and flow control as well, right? We can do a lot of things. We have it in mind, yes.
That's good. I'll not take the floor longer.
Thanks.
François Michel, Apple. Thank you very much. I was at the hackathon. I implemented the minimal example that you two came up with. So I would like to thank you for that. Thank you for agreeing on the design on a minimal solution. What I would suggest is to continue on that path and continue to agree on parts of the protocol you would like us to implement to do interop with you. There are currently 2 drafts. Most of the drafts are pretty similar, actually. There are several differences. One is the use of multipath. The other is how you handle authentication and integrity. But I think there's a good common ground between the 2 drafts. So I think it would be helpful if you could agree on some part so that we could move forward and continue interop.
Thanks. Yeah. Also, to maybe add to this briefly, is that we actually got public funding now. So for at least the next year, we will work on this. Have multiple people work on multicast Quic full time, one way or another. Yeah.
Magnus Westlund Eriksson. I do think having a multicast extension for Quic would be something very useful in the toolbox. I think there's a number of use cases. There's clearly problems to work through to give robust, secure, and reliable behavior in a number of cases, including congestion control, ensuring that you have the right security properties, etc. But I think it's time that working group maybe steps up to start working on this.
Yes, thank you.
Hello, I'm also interested in the multicast use case. I had a question though about the end-to-end security guarantees that you had touched on. It seems like if you're going to do a multicast where you're having a relay be one of the endpoints in which you're sending the unicast connection and into multicast through, that end-to-endness is actually going to apply from the source to that relay and not necessarily the multicast ends. Can you touch upon that a little bit?
So yes, how the design works is basically you have the unicast connection as the secure anchor, right? And through that you exchange all the security relevant bits. The trade-off you have is that you share the keying material between all the receivers, right? But the connections, everything is still encrypted. It's just all the receivers share the key, so you get all the trade-offs you get from that. One of them is, of course, that you could do packet injection, right? Like any of the receivers could construct a packet that confirms with the AAD, but for that we have the integrity frames, which are basically hashes against the packets, right? And they allow you to uniquely verify that the packet was actually sent by the source itself and not injected by some man in the middle. But that's how far we got so far, right? Or what's what we have so far.
Right. So I guess stronger notions of authenticity are not necessarily going to be covered in that key sharing sort of way of doing this, right?
Exactly. For the authenticity, you need the integrity frames. Yeah.
Yeah. Okay. Thank you.
Hey, Etienne Deschamps. There's something that I find very intriguing with the idea of using Quic as like a control channel here is, and especially the fallback from unicast to multicast is, you could, if for some use cases, are you considering having retransmissions on the Quic channel so that I'm getting a multicast stream, but then I missed just one packet, and I can ask on the Quic channel, please give me that single packet so that I can
Yes,
catch up.
exactly. That's. I mean, again, we could talk about this for 3 hours, but the point is, yes, you can do retransmissions, right? This is reliable data through multicast, and you can even go as far as say, okay, I noticed a lot of receivers have lost this packet, and I can retransmit it through a different multicast channel to get it to multiple receivers at once, or I can retransmit it through the unicast channel individually to the single receivers to get it fully right. But for things like file transfer or whatever, it's you can do it.
Thank you. I'll be quick. No pun intended. Did you say that you have a different security framework for the content than from what you use for Quic itself for the individual legs?
Sorry, can you repeat? Sorry.
Did you say that you have a different security framework for the content end to end?
No, we use the same keying mechanisms that Quic uses, but because the keys are shared for all the receivers, right?
Yeah.
You have this integrity frames in addition to that to prevent forgery and injection, right? That's.
Oh, additional integrity frames.
Yes.
And those are end to end encrypted between the source and the receiver.
Yes, you can. There's different ways to do this, but you can send those on the unicast connection, right? And so they are encrypted
Okay.
fully. Yeah.
Got it. Thank you.
Yeah. Thanks.
Okay, so kind of trying to summarize that discussion, I might get this wrong. That seems like a certain set of people are interested, and that there is potential driving use case maybe in the mock space, but the mock working group's very busy. There's a suggestion in the chat that maybe this is a topic that would benefit from a BOF of some kind. I don't know. I think we should probably get together some of the chairs and the ADs and talk about this topic. It's been presented in the past. There was a lot of interest back then. It would feel sad if we just did nothing and made these folks wait and come back again in a year's time when their funding had just run out. So yeah, maybe we can find some time this week to do that. But, yeah,
thank you.
Thank you, Max. Close. We have a few minutes, so you have all of the rest of the agenda to yourself.
All right, hello. So yeah, I'm Floris from Number Zero, and together with my colleague Diva, I have been spending a little while implementing multipath and hooking that up to NAT traversal. This started out as a fork of Quinn. You can find it there. And I also wrote up a little bit how we do the NAT traversal. Does this move? Oh, yeah. So a very quick overview of like how we get this to work is like we essentially assume that the connection gets established via relay path. The Quic stack just sees this as another IPv6 unique local address. So it's just a normal path. So we establish path 0 over that essentially, and then we do the hole punching coordination of that. Usually the IP paths, the direct paths, are not immediately there, and we need to hole punch those. So once we start hole punching, we do this with normal path validation, so path challenge, path response frames from RFC 9000, and once the paths, once the probes succeed, then we open that as a new path. We base this on the draft from Martin Seemann, Quic NAT traversal, and we bear some familiarities with this. So just like in multipath, the client actually drives the whole thing. So the server can only advertise its address candidates. It does this in these add address, remove address frames. And then whenever the client wants to actually initiate NAT traversal, then it sends out, in our case, this is where we differ from the other draft, we send out the reach out frames. The reach out frames basically each contains an IP address, and you usually send those in a bunch. Once, at the same time as we do that, basically that's like NAT traversal initiation. So the client will at the same time send path challenges to all the address candidates that it received from the server at this point. And the server, when it reaches a bunch of reach out frames, will do the same. It sends path challenges to all the addresses in the reach out frames from the client. If you do that, if you retry those a few times, hopefully you will punch some holes. So we don't follow the ice pairing kind of thing. This is kind of not necessarily because we don't like ice pairing, but it was a way of keeping this kind of very close to what we already had. The probing is kind of a path. Yeah, I have to go fairly quick, I think. Does this move? Yeah. We initially abandoned, we initially tried to do the probing, at least on the client side, using the correct path ID already of a new path. We had to abandon this because this just created too much path churn. The problem with the path churn was that basically each path, like every time you have to abandon a round, you had to consume a lot of CIDs. You had to wait till the peer increases the max path ID, until the peer issues new CIDs, and only then could you start kind of probing again. This does mean that we had to kind of introduce the notion, like if this extension is negotiated together with multipath, we do bring back the notion of probing frames, because otherwise you cannot do off-path probing on multipath, because every packet is a migration. The benefit of that is that it's actually completely orthogonal to multipath in a way. You could actually do this with normal, without multipath as well, which is kind of elegant. As I sort of already hinted, issuing CIDs was a big problem for us. We kind of skirted around this by currently all our paths are linked. That's very bad. We need to solve this. But we really, like in our earlier attempts, we had like a couple of kilobytes of CIDs at the beginning of a connection, and that was just not workable. So we will try kind of interleaving these with reach out frames probably. Otherwise, completely more radical is like, can we negotiate some sort of shared key and an algorithm to generate CIDs, and then you have just CIDs as many as you want? That's quite unlikely. That would not be the ideal outcome, but that was just an attempt at like trying to think of what can we do. Probing packets in multipath, I already mentioned. It was kind of make sense for us to bring that back, and it made it like much nicer. So that's kind of an interesting outcome for us. And the last point, I haven't really talked much yet, but yeah, ideally we kind of want to establish one connection across multiple paths, and we don't know which of the remote endpoints will be alive, and we would like that to be a single path, single connection, sorry, with multiple paths. We were thinking of like, can we open this directly on different path IDs? Speaking to other people already here, maybe it makes more sense to actually give this separate connection attempts, and then on the client throw one away. There are some trade-offs there as well. Yeah, that's all I have.
Yeah, we're at time. So thank you. This is Flawless's first Ietf. The peer-to-peer kind of use cases are not strict. I don't even know if they're in Charter, but extensions and building blocks to Quic that could enable such use cases potentially are. So I encourage anyone interested in this space to reach out, or you to reach out to them, and maybe, you know, quite early right now, but this is something we could discuss on the list, and maybe bring back in the future once we figure out some of these open questions. So, and with that, I'd like to thank all of our speakers and the AI Minute Taker, and we'll see you on the list. Thank you, everyone.